Good afternoon, everyone. Today, I would like to share about the conversion of alkene to alcohol. This is one of the example, and this is 3,3-dimethyl-1-butane. It reacts with the H2O, and the H2SO4 will act as acid catalyst, and it will produce 2,3-dimethyl-2-butanol. Alright, now we will talk about the first mechanism. It is formation of carbon cation by protonation of alkene. The double bond in 3,3-dimethyl-1-butane has a pi bond which is rich in electron. This electron can act as a nucleophile which is able to donate. The pi bonds are less tightly held than the sigma electron in a single bond here, and making this region generous in donating electron. And the H2SO4 is the acid catalyst in the reaction. In the H2SO4 here, the oxygen is more electronegative than the hydrogen, and it creating a partially positive charge on the hydrogen atom while partially negative charge on the oxygen. This made the hydrogen electrophilic, which is attracting to the electron from the alkene. The double bond electron in this compound reach out and snatch one of the hydrogen atom, like the arrow that I have drawn in here. This snatching break the double bond in the process. It will, for easily to understand, is the electron will be transferred to the H electron from the H2SO4 and breaking down the double bond here. And here, the two electrons shared by the hydrogen and oxygen will move toward the oxygen, which is hungry, or we can say hungry for the electron, and this creates the HSO4 ion. Now we will enter the second mechanism, which is the rearrangement. And the attacking move by the 3,3-dimethyl-1-butane double bond form a new connection with a hydrogen from the H2SO4 by breaking down the double bond. So in this situation, we will following the Markovnikov rule. The hydrogen will go to the carbon with more exciting hydrogen, like here. If we compare, like before, this is the this is the place where the double bond is, and after we break the double bond, we can see if we compare this to carbon, this carbon will have more hydrogen actually. So actually, Markovnikov rule help us to predict the main product by consider its stability. And here it will form a secondary carbon cation, so it can better to handle the positive charge due to a more neighborly atom. In the carbon cation stage, a nearby hydrogen, or we can say here is the melting group. This melting group and this positive charge actually will exchange the place. Because if the positive charge only here is actually only from secondary carbon cation, but if it change with the melting, it will form tertiary carbon cation, which is made it more stabilized. We call this process the process that the positive charge change position with the multi group. We call it 1,2 multi-ship. By following the 1,2 multi-ship, a more stable carbon cation is created. Now, the positive charge here is sit on the tertiary carbon cation, which is more stable than the early secondary carbon cation. And this rearrangement results in a more secure and effective reaction due to the increased stability of the carbon cation. And here we will continue to the third one, formation of protonated alcohol by the adding H2O, which means that in this step, water will join as the nucleophile. It use one of its lone pair. Here we can see there is two lone pair, but it only use one lone pair to attach to the positive charge here. So after the lone pair react with the positive charge here, it will create a fresh connection between the carbon and the oxygen, forming a carbon-oxygen bond. When we can see here is the carbon-oxygen bond. And this is newly bonded atom has a positive charge because of the formation this new carbon-oxygen link. Alright, now is the last stage, which is deprotonation of protonated alcohol. In the last step here, a hydrogen atom is taken away from the positive charge oxygen. We know that why the oxygen now have a positive charge, because it's already react with the positive charge that include in here. So it will form our final product, which is 2,3-dimethyl 2-butanol. And the HSO4 here actually act like a base, grabbing the hydrogen, like it take the hydrogen atom from the positive charged oxygen, and this cause the bond between hydrogen and oxygen break, which this bond will break, and it will share before it break, we know that there is share electron in here. So after the H is bind with this, and the electron here will move to the oxygen, because we know that oxygen is more electronegative. And the last product, 2,3-dimethyl 2-butanol, is made by removing a proton. It is essential to highlight that using sulfuric acid as a catalyst is vital. It actually helps add a proton to the alkene and set the stage for water to join in. So if without the H2SO4, the reaction will become really slow. So the cool part is the acid catalyzed get back, like we see, if it join with it bind with the hydrogen atom from the water, and it form like just like the enzyme back to the original. So actually it can be reusable. So I think that's all for my explanation. Thank you.